Hello 108 students, Mr. McHugh back with you here again. Believe it or not, this is my second crack at this. I made a video and accidentally wiped it out by giving it the wrong file name. So we'll do it again here. We're on page 2, section 8.4. We're going to now work with radicals with higher indexes. That means like cube roots or fourth roots. Same technique as before. The big thing is you got to be in what I call cube root mode in your brain. You're taking cube roots. And you got to remember to keep writing that cube root every time you're doing these problems. If you drop that cube root, you'll think it's a square root and it's going to mess you up. Okay. Other big thing here I got on the side, I said learn. You need to make sure you memorize your perfect cube root tables. Memorizing is a little hard here, but you've got to keep them down. I also keep talking about that radical table sheet that I have included here. I'm going to post it here soon, so use that, print it out, and it'll help you out. So we're talking about this. If you see 64, can you take the cube root of it, perfect cube root? The answer is yes. The answer would be 4. Cube root of 216 is 6. You don't have these memorized as easy, so you've got to have them handy. Okay. Now here's the idea. Take a problem and break it down into try to find a perfect cubed root factor. So 16 can be broken down into 8 times 2, but the cube root of 8 is a perfect cube root factor, which will result into a 2. That's the thinking you want to go on. Okay, so break them down. 8 times 2, 54 can be broken down into 27 times 2, and the cube root of 27 is perfect cube root, so that result would be 3. Okay, now that's how you want to handle these. So bring down the 2, bring down the result of the cube root of 8, bring down the cube root of 2 minus 5 times 3, again cube root, times the cube root of 2. Okay, now the idea here is multiply numbers here. 2 times 2 is 4, 5 times 3 is 15, so you're left with this sub result. And the good news is, do you have like radicals? Same index number, same radicand, so the answer is yes. Simplify by taking 4 minus 15, and there's your answer, -2 times the cube root of 2. Okay, got the idea. What are you going to do with variables? The big thing here is, way back when we talked about simplifying radicals, we talked about it didn't make sense when I first covered it, but perhaps now it will. You need to, when you're simplified a radical, the exponents need to be less than the index number. Here in this case, the 2 and the 1 are less than the cube root of 3, so you're fine. There's nothing to simplify. Over here, cube root of 8, you could break that out. Cube root of x to the 5th can be broken down into x to the 3rd and times x to the 2nd, because why? X to the 5th is broken down x to the 3rd times x to the 2nd. Add the exponents, but I want to take cube roots, so don't forget to put that there. And the cube root of x to the 3rd is x. X times x times x is x to the 3rd. And when the index is greater than the exponent, or the exponents are less than the index, that's in simplified form. There's nothing else you can do. Okay, so we turn around there again. Be neat, be organized. Break apart, pull out the perfect cube roots. Now go ahead and execute them. This guy we left alone, like I said here. The cube root of 8 is 2. Cube root of x to the 3rd, x, y. And you've got the cube root of x squared times y to the 1st. Nothing else you could do with it. Then you turn around and you look and you say, oh, do I have like radicals? And the answer is yes. Same index. You got a 3 and a 3. Same radicand. X squared, y in both of them. Therefore, add the coefficients. 2 plus 2xy. Add them up. Multiplied by the radical. And there's your answer. Okay. So we're cruising. You're doing pretty good. And then example C. They're going to mess with you just a little bit because they're going to go in mixed mode. What I mean by it is check the indexes. You've got what? The square root. This is a 2 if you wanted to pop it up. This is the what? Cube root. Okay, your indexes are not the same. Best advice I could give you here is so you don't go crazy between square root and cube root mode in your brain. Do these problems separately. Do the first one. Bring down all the plus signs. Then do the second one and do it. Okay, so let's try that format. You're in square root mode. 5's on the outside. Bring it down. Square root of 4. I would take it apart because you get the perfect square root. X squared is the perfect square root. What's the result of that? 2x. 2x times 2x is 4x squared. So you execute the radical. You get 5 times 2x, and the result of that is 10x. Okay, the square root of x Where did that come from? X to the square times x to the first. Remember, when you multiply by the same base, add the exponents. 2 plus 1 is 3. So you had to bring it up there. You don't show the 1, but you can't take the index is less than, excuse me, careful, the exponent is less than the index, which is an assumed 2, so it's in simplified form. Okay, take the other half of the radical. It's in cube root mode. Can you take the cube root of 64? Yes, I set it apart. X to the fourth, break it down to x to the third and x to the first. Why? Can you take the cube root of x to the third? Yes. And that would be what? X, sorry, over here. And cube root of 64 is 4. You drop down to 3, and you've got the cube root of x you're bringing along. Then you realize you do not have like radicals, so therefore you leave them alone and clean up your results. 5 times 2x is 10x, 3 times 4 is 12x, and there's your answer. Okay, class, I just got a note here. Be extra careful with cube roots. They are not square roots. Don't forget the index. Number 3, and drop it. What I'm talking about here is an classic example. You're taking 64, you're taking the cube root. 64, and you write, in your head you think this is, you forgot to put the 3 in there, and you go 8 times 8 is 64, and then of course that's the wrong answer. They want you to take what? 64, take the cube root, and that would be what? You're not sure? Come up to your table. 4 times 4 is 16, 16 times 4 is 64, so that answer is 4. Okay, Mr. Q, here we have finished up section 8.4, page 2. It's in the book, so I will see you for the last page 3 here, and we'll wrap this up. Okay, take care. Bye-bye.